Hello all, I'm Dr. Vishnu, Assistant Professor of Chemistry. Now, I would like to discuss one of the famous gaseous fuel, hydrogen fuel. Hydrogen fuel is a clean burning energy source that generates just water vapor and heat when utilized in a fuel cell. Let us see this hydrogen car. So, in this hydrogen car, you can see there is one hydrogen tank. So it is a fuel tank in which hydrogen gas is filled and it consists of one fuel cell. So this is a hydrogen oxygen fuel cell. So when the car is run, the hydrogen gas and the oxygen continuously fed into the fuel cell so that the hydrogen is burnt completely in presence of a alkaline catalyst and it will be producing water. That means, so this is the reaction happening H2 plus O2 giving rise to H2O in the hydrogen fuel cell. So here, the when you check the net emission, there is no carbon. Only hydrogen is emitted or released in the form of water. So that is the reason one can call it as a clean burning energy source. So this hydrogen fuel is a multifaceted energy carrier with potential applications in transportation and electricity generation. So here one of the important thing is when the hydrogen is burnt, it produces very high calorific value. So about 34,500 kilocalories of energy is produced when a kg of hydrogen is burnt. So that is the reason it has very important applications and are the research is going on to develop the hydrogen based vehicles. So, and one of the main advantages is this hydrogen is most abundant in the universe, but mostly it is in combined state with water. So that is in combined state with oxygen in the form of water, or maybe with hydrocarbons. So hydrocarbons, all of the hydrocarbons. So carbon, it begins with the methane, ethane, propane, so on. So there are many hydrocarbons which consist of the hydrogen combined with the carbon. So to produce the hydrogen, this hydrogen has to be separated from the oxygen or carbon. So maybe from renewable sources or sometimes from the non-renewable sources. So you can see this water is a renewable source and hydrocarbons are mostly fossil fuels which are non-renewable sources. So to differentiate the different process of extractions, so there is a hydrogen color code has been created. So this color code indicates the source of the production as well as extraction process. So here the most famous hydrogen color codes are green hydrogen and blue hydrogen. So let us see one by one. First, production of the blue hydrogen. So this blue hydrogen is produced from the natural gas, that is methane. So natural gas or methane is treated with this steam. So this technology is called as steam methane reforming. Steam methane reforming technology is used to produce the hydrogen or capture the hydrogen from the methane. So simply this natural gas is mixed with the hot stream along with a catalyst so that what happens, it will be converted into carbon monoxide and producing the hydrogen. So carbon monoxide is very dangerous here, it is toxic one. So immediately this carbon monoxide hydrogen mixture is treated with the additional water so that this carbon monoxide is also converted into carbon dioxide by releasing the hydrogen. So now there is a carbon emission here. So this carbon dioxide may be released or captured. So when it is captured, it can be stored underground using carbon capture technology. So this hydrogen is called as blue hydrogen or named as the blue hydrogen. Here nearly zero emissions can be observed. So when you see this schematic diagram of the production of blue hydrogen, so here this is the natural gas, nothing but the methane gas which is fed into this reactor along with the hot steam. So both are combined, and this steam will extract hydrogen from the carbon, and which is converting the carbon into carbon monoxide. You can see this white color dots may indicate the oxygen, and this blue color dots circles will be indicating the carbon. So a carbon monoxide is formed. Now by passing the steam, that is additional water to this carbon monoxide hydrogen mixture, the remaining uh, carbon monoxide is also converted into carbon dioxide. You can see two oxygens are attached to this carbon. So in this way the carbon dioxide is formed, and hydrogen is completely separated from the methane as well as the steam. So the carbon dioxide so released may be removed or stored using the carbon capture technology underground. Next, production of the green hydrogen. So it is called green hydrogen because it is produced from the renewable sources, especially using water. So water is subjected to electrolysis process so that it splits into hydrogen and oxygen. So both are useful. Hydrogen is collected in the cylinders, and oxygen is also collected in the cylinders. So hydrogen is used as a fuel, and oxygen also can be supplied to the hospitals. So since water is a renewable source, and one more thing, the electricity used for this electrolysis process is also from energies, renewable energy sources like wind energy, hydropower, hydropower, and solar energy. Then only you can call it as a green hydrogen. So there is a zero emission. To produce 1 kg of hydrogen, it requires about 10 liters of deionized water, which is called as green hydrogen. Production of green hydrogen, you can see. So this is a setup, typical setup of the electrolysis process, in which we have anode, this is anode, and other side we have cathode. So near the cathode, you can see the production of the hydrogen. So by electrolysis process, water splits into hydrogen and oxygen in the form of gas. So that upper arrow indicates the gas over here. Now we compare the blue hydrogen with green hydrogen. Blue hydrogen versus green hydrogen. If we see, the blue hydrogen has only one disadvantage, that it is dependent on the natural gas. So natural gas is a fossil fuel. It is a non-renewable resource. So this is a main disadvantage of the blue hydrogen. When it comes to green hydrogen, it is produced from the water. So water is a renewable energy source which can be produced by electrolysis technology. In case of blue hydrogen, we can see carbon dioxide. So carbon dioxide obtained from the reforming of natural gas has to be captured and stored, whereas in green hydrogen there is no emission of the carbon dioxide at all, so need not to stored or released into the atmosphere. So zero emissions. Next, blue hydrogen setting up the industry, low initial production cost compared to the installation, but this electrolysis technology of the green hydrogen plant is expensive, but it is more cost effective during the runtime. When you compare the emissions, net carbon dioxide emissions, blue hydrogen releases about 3.5 to 4 kgs of net carbon dioxide to produce 1 kg of the hydrogen gas. When it comes to green hydrogen, so zero emission of the carbon dioxide to produce a kg of the hydrogen gas. So anyway, if you compare, green hydrogen is eco-friendly when you are using the electrical energy source from the renewable sources. And here you can see uh, comparison of these two green and blue hydrogen plants here. So the first one is a green hydrogen plant. Now you can see, so wind energy, solar energy, These type of energies are used, both are from the renewable energy sources. And you can see this is a electrolysis process in which we have electrodes. These electrodes will break the water into oxygen as well as the hydrogen gas. So this is the hydrogen gas which is captured or collected into the cylinders. So this is a green hydrogen production method. When it comes to blue hydrogen, so this methane gas is extracted from the oil wells. So this methane gas or natural gas, it is subjected to the steam reforming in this tank, so that the carbon dioxide is released and hydrogen gas is collected into the cylinder, and this carbon dioxide is either released into the atmosphere or stored under the soil. So, however, green hydrogen produces zero emissions, and blue hydrogen produces the carbon dioxide. So, in this way, one can compare the green hydrogen with the blue hydrogen. Thank you.